Coming up at the 1 o'clock slot with crap on his shirt from something, we have Mr. Joe Obbish and Erik Darling doing the problem with optional operators. Take it away, Erik and Joe. Now, the thing that I have to say very first is that this is what happens when you let people write introduction slides for each other, and they're on a very friendly basis. So this is Joe, and this is what I think of Joe, and you can just take a moment to scan that list. That's Joe, and this is me, and this is what Joe thinks of me, and I'll give you a moment to read that list, and then we'll move on.
Pretty short moment there.
Yeah, well, we don't need a long moment. We don't need long moments for these things. That's why we wrote them that way.
Yeah, fast readers.
So we're here to talk about optional operators, and we're going to start this talk. We've agreed, barely agreed. It took a long time to come to terms. I was going to explain what an optional operator is, and an optional operator comes from the query optimizer being able to make choices about how it's going to construct a query plan. It makes all these choices based on how much different things cost. And it measures those costs in these imaginary CPU and IO units that are only known to the sages of Redmond. The cheaper plan, the cost of a plan, that does not dictate how long a plan is going to take to run. It used to mean that a long, long time ago, but not anymore. Nowadays, the cheaper plan doesn't mean the faster plan, and it doesn't mean the best plan possible. When you look at an operator and you see the cost on it, the cost is just like a price tag. The only thing SQL Server cares about is how much that operator costs. If it found a really cheap way to do something, it's going to stick with that cheapskate way to do it. It doesn't care about bells, whistles, ding-dongs, flags, any streamers, cool anti-lock brakes, sunroofs. It doesn't care about any of that. All it cares about is getting the cheapest thing possible. There are times when getting a bad operator is your fault. And bad choices aren't just limited to query plan operators, like those things that show little pictures that show up in there. Sometimes some of the information, some of the details of the plan can also be bad. And all of those things come from bad guesses. So if we write a query that the optimizer can't make a very good guess about, the optimizer is going to sit there and say, oh, well, you want to know how many posts in this table? You want to know how many of them have more than 10 years between when they were created and when the last activity was? Well, say about 5.1 million. Even though 0 rows actually qualify for that, SQL Server just made a dumb guess because we wrote a query in a bad way. And so if we ask the same question, just about a slightly different number, like, well, how many have less than a year between them? Well, 5.1 million, even though about 14 million actually qualify for that. So SQL Server is just throwing BS numbers at us. It's making bad guesses because we kind of wrote a query terribly. Bad guesses lead to bad choices. Look at my life. If you were this guy and you dress like this and you were going to a cafe, you have made a good choice. When you end up in the toilet section of a hardware store, you have made a bad choice. This is no longer appropriate. You should no longer be dressed this way. Stripy shirt, little scarf, floppy hair, you're out. You do not belong here, sir. Those bad choices carry over to other parts of the plan. So if I now have this query that we know is going to make a bad guess, and now I want it to do other things, some slightly more involved things, those bad guesses are going to impact stuff in the plan. Like, for instance, when I run this query, and now I'm going to do some sorting and some grouping and stuff, and I'm going to run this query, and we're going to get a little warning in the plan. We're going to get that little ding on the select operator. And we have to be very careful here because this may impact the reliability. That 26 megs of memory is going to impact it. Be careful there, sir. You have impacted the reliability. When we ask that query to do now something bigger with more rows, you can imagine what's going to happen. This is just going to get worse. But don't worry, because it doesn't impact the reliability. We just spill all that crap to TempDB. No big deal. No one cares about that anyway. No one's worried about TempDB. But let's face it. When it comes to this sort of stuff, when it comes to this sort of like bargain basement material, you've heard all this stuff before. You've heard write sargable queries. Oh no, there was a function. Isn't that cheeky? No one ever saw that coming. No wonder the query's so slow. Maybe you used a table variable. Maybe you just didn't create an index. You sly dog. How did you ever come up with that? Maybe you didn't update stats. Maybe you just should have used a temp table. There's all this stuff that's just like, yeah, I've heard it all a million times. Granted, people keep making those same mistakes, and that's kind of why I have a job, but it's not what I always want to talk about. Sometimes I like figure, and the reason that me and Joe are friends and we can call each other duty heads is because when we talk, we like to talk about when the optimizer makes bad choices on its own, like when we don't screw up, when we do everything right, and we're like, hey, wait a minute, this thing is still totally wrong. When it's not your fault, well, the optimizer can choose all sorts of weird things to stick in your query plan that are really, really bad choices. Some of the ones we're going to look at today are spools, lookups, sorts, a top operator, and bitmaps. So all interesting, fun things that you don't hear about in every single presentation when you get into performance tuning talks. A lot of them will just focus on some silly thing that you did, some best practice that you violated. This is when the optimizer goes and screws the pooch on its own. So I went one slide too far. I'm going to pass this over to Joe. My first sign of complete irresponsibility. I'm going to make Joe presenter, and Joe is going to show us some interesting stuff on his screen. Hopefully he has hidden the anime girls before
they're all hidden.
Starting this out.
I've hidden all the evidence of
yes.
everything.
All right.
Can you see SSMS?
Oh yeah, you're good.
Okay. So we have a very simple fact table here with some orders in it. This table was born and it never really grew up. It's still a heap. It's in its natural state. We have, some pretty typical boring columns. Got an order date, number purchased, the price, the unit ID, and then this unit class ID.
A money column.
Very simple table. 5 columns. Also using a date dimension table from Aaron, and here's the URL to create that.
You want to take advice from a guy who just ran over a screw? It's your big idea?
Well, that was today, and I think you wrote this article a long time ago, so that really shouldn't apply.
Yeah,
right?
He was young and sober then. Who knows?
All right, yeah.
I still have to figure out what's on my shirt.
Okay, so let's say today's task for the day is I want to take my orders table, join it to my dimension table, group by the last day of each quarter and my unit ID, and also in the same result set, I want to do something similar. Here I group by the unit class ID instead, and I have just this one simple aggregate here. Now, I'm looking at this query, and then I remember, oh, well, there's this thing called group by grouping sets I've seen on the internet. Some people say that that's good, right? So this query is the exact same thing as before.
Well,
it'll give me the exact same results. Right. I mean, I want to write as low code as possible as a developer. That is one of my primary goals in life. So the way you interpret this grouping sets is the same query as before, where we group by the first one, union all, and then we group by the second one, right? So I've got a nice compact query here. I would run it, but it would take too long. So here's our actual plan instead.
Optimizer, what are you doing?
It took 30 seconds. One of the things that I do is I take queries and I make them run faster. 30 seconds, I don't think 30 seconds is very good.
No,
so let's figure out why this query is slow. So this is a row mode serial query. I can look at the actual time stats per operator. And the sum of the time here is for that operator, and then that also includes all of the child operators as well. So my scan on date dimension, that takes 1 millisecond, okay? It's probably not the problem, right? My scan on the fact table, it's 1.2 seconds, okay? It's not the problem either. Can look at this hash join, so that's 3 seconds for the hash join and the 2 scans. Look at this spool though.
Oof.
It's 24 seconds minus 3. So SQL Server took 21 seconds to write that data from the join into the spool, and then the rest of the time is spent on the aggregates.
There ought to be a trace flag.
There ought to be, and maybe there is, and we don't know about it, right?
We have Forrest tell us if there's a trace flag for that.
So what's the strategy behind this query? So the optimizer really only has two choices here. It can run each aggregate individually and union them all together, or it can take the results of when aggregating, put it into a spool, and then apply the spool to apply the aggregate to the spool twice. So if you imagine if I had, let's say that this query was actually very expensive to calculate, and it didn't produce that many rows. The strategy of take the result set, put it into a spool, and run aggregates on the spool for as many times as you need to, that could be a good strategy. But here, I'm throwing 9 million rows into this, and I'm spending 2/3 of the time just writing to the spool.
So, Joe, we have our first great question. Lee asks,
ready. Okay,
I'm ready. 21 seconds. Why is the cost estimation 0? Is time to do a thing not considered in the estimated cost?
Why? That's a good question. So these are just estimates, right? They can always be wrong. Now, I don't know why this is costed a 0. It's kind of a weird thing here. Reading from the spool has a cost of 20%. So I wouldn't. So the cost percents are often wrong. Like these cost percents are based on the estimated plan. You could put it that way. This is our actual plan. Yeah, I don't know why this has a cost of 0%. That must be some kind of weird optimizer trick. But in any case, SQL Server thinks that this is a good enough plan. I would say it's not. So a few disadvantages here. Writing to the spool is always in max stop 1. All of the aggregates off that spool are always to max stop 1. And there's a lot of overhead for writing to the spool, even compared to writing to just a normal temp table. I want to speed this query up. I don't like what the optimizer did. So I'm going to, instead of using a spool, I'll just take that initial result set, write it to a temp table, and then I will aggregate on that temp table. And to keep things fair, I'll have both queries be max stop 1. Go ahead and run that. Now you might think, well, this shouldn't be faster. I mean, writing to an eager spool, writing to a temp table, I mean, why should that matter, right? But it turns out that it is faster once it finishes.
We have one execution plan, so we're good there.
Yeah, okay. So we went from 30 seconds to 22, and I think some of this time was spent doing I/O, but the only change I made was, okay, I don't want a spool. I often don't like spools. I'll write to the temp table instead. And here, for the grouping sets query, I mean, I'm just pulling from one table, right? It would be totally pointless to take that table, put it into an eager spool, and then aggregate based off that. So SQL Server doesn't do that. It's smart enough to split up this grouping by sets query into a pair of aggregates, and we saved a bit of time just by avoiding the spool. Now, there's really no reason to keep the max stop 1 hint, right? That's just kind of an artificial thing to keep things fair. So I'll go ahead and get rid of that hint, and I'll also combine my aggregate into one column because why not do that? Let's see how this query does. So the same query, I'm letting the optimizer run it in parallel if it so chooses.
Oh, there's an execution plan, boy.
So we went from about 21 to 14. Just interesting. That would be better.
No, that's what they all say.
Yeah, it was running faster an hour ago. What is the deal here?
It's WebEx, probably. Oh, you get all those CX packets. Takes time to fill those up.
CX
Put it-
packets, gotta fill up our packets. Yeah, I don't know what SQL Server's problem is.
You tried
but
turning on jumbo packets?
not yet. So I'm on SQL Server 2017. I can do parallel sucked into. There's a lot of parallelism going on here. There's a lot of parallelism going on here too. So I'm not saving any CPU time. In fact, I'm probably getting a little CPU time due to these repartition stream operators, but the query ends up running faster. Okay, so 14 seconds isn't bad. I think we can do better. What do you think, Eric? Can we do better?
I always think we can do better.
All right, so I'm not a fan of these repartition stream operators.
Which are
They
also
don't scale
optional.
well. And they're optional, yes, that's one reason I'm talking about them. So what SQL Server is doing here is, this is a row mode parallel hash join. And the way it's implemented is, you can think of an independent hash join on each parallel thread. So for the join to work, we need to make sure that on thread 1, all of the corresponding rows from both tables are on that one thread. If they weren't, then the join would end up losing results. So what SQL Server often do is, it'll partition using an internal hash function to make sure that we don't have any mismatched rows. So here we're doing additional work. We might be sending rows from thread 1 to thread 2, or thread 2 to thread 3. Now this is a totally normal thing to see with parallel row mode plans. It's part of the deal you make if you want parallelism.
Deal with the devil.
Pretty much. And here, I mean, here for the aggregates, it's the same thing, right? So for the aggregate, you can think of it as a bunch of independent aggregates, one on each thread. Again, we can't, if we didn't adjust our rows and apply hashing function, we could get wrong results. So this adds some overhead. I'm running a max.4 only because I'm running locally, so it's not that bad, but it's still time we don't need, and it's time caused by an optional operator. Now running it in max.1, of course, makes all these things go away, but now you're running a max.1.
Which is a bummer, because you paid a lot of money for all those cores.
Well, I didn't pay anything, but my understanding is some people pay
nice people out in the real world pay money for those
in the
cores.
real world, yes. So I'm going to do something that is unsupported and join to an empty CCI with a join condition that can be optimized out.
Tell the nice people what a CCI is.
A CCI is a clustered column store index. I'll go ahead and run that. So I'm on 2017. If I want my query plans to be eligible for batch mode processing, I need to have at least one column store index referenced in the query. So before it took, what was it, 14 seconds?
14 seconds.
Now it took 5. Okay.
I like it.
Quite an improvement, right? Yeah.
Like so we're down from like 30 something seconds to 5 seconds. I think we're doing well.
We're doing all right. We're not done.
It's okay. I'm all right with that.
So this is all parallel, but our repartition stream operators are gone, right? I mean, they're the mandatory ones at the very end, because whenever you're selecting, all the rows have to go to one thread. That's just how it works. But the difference here is, this runs in batch mode now.
Nice.
So batch mode processing, it can be more efficient. The big benefit here is that batch mode operators, they all internally handle thread management on their own. So there isn't the need to move rows around between threads. That's just built in. And
it just runs faster.
Sometimes it just runs faster. Now batch mode is especially suited for aggregates and for hash joins and for parallel queries. So this is a very similar plan than before. It's just everything runs in batch mode pretty much. We've gotten rid of those repartition stream operators, and things on the whole are just more efficient. Now, can we do better? I mean, let's see.
What's better than 5 seconds?
So we're taking about 3.2.
Okay.
Running to the temp table.
Okay.
And then we're taking what? That would be 1.7. Be
I don't know.
1.7
I
for the
can't do
rest.
math. You went to college. Come on, man. Don't make me do
So,
math.
I mean, like the only reason this temp table is here is because, well, the optimizer chose a spool. I was trying to keep things similar, right? I mean, we don't need the temp table.
No.
I'm gonna get rid of grouping sets.
It's just rented space anyway.
Yeah, like get rid of grouping sets. So I'm writing this out the long, boring way. Let's see what happens. As far as I know, the optimizer will not pick that eager spool plan here. It's just not coded to do that. All right, so it took 11 seconds. There's no longer a spool. So it performs this join twice instead.
Bummer.
Which is a strategy that it can choose for grouping sets, but this is the only strategy if I don't use grouping sets. All right, I mean, so before it was 30 seconds, now it's 11. That's not bad, right? So we're back in row mode. I got rid of my empty CCI.
Oh, you'll be getting it that
So
back.
why not add batch mode back, right?
The repartition streams like the middle part of query plan choices is bad.
2 seconds.
Whoo.
No longer any repartition streams. Pretty much everything runs in batch mode. I think every operator does, except for the scans, because these are row store tables around 2017.
What do you think this is? 2019.
These could run in batch mode too. And then I think everything else is, well, this isn't row mode, but we're not spending any time here. So I started with that grouping sets query. The optimizer thought, well, instead of doing the join twice, maybe it would be better to take that join, throw it into a spool. That's not a good fit here. There's a lot of overhead when writing to the spool. We write to the spool in max stop 1, and all the aggregates off that spool run in max stop 1. So to get from that to a faster query, I got rid of grouping sets, I added batch mode, and that's really all I did. So I wouldn't say the grouping sets is bad, but if you need the best possible performance, and if you have a spool, in my experience, there's often a way to get rid of that spool to make performance better. At the end of the spools demo, are there any questions?
We'll wait a second to see if anyone comes out. So there's one person's typing, so we'll let that slide in.
Okay.
Hiram wants to know why you use the column store hack on the top query and not the second one as well.
The second one. By second one, do you think it's meant by the union all query?
Yeah, because it looks like you're joined to the batch mode table there, but not on the second one.
Oh, well, sure. So this is one query. So all I need is one column star index in the query. Before, when I was writing to a temp table, these are two separate statements. So if I only had batch mode here, then the second query wouldn't be able to get batch mode.
Right. No essential parts of the second query were in batch mode. In other words, like that one temp table being present allowed any operators that could be in batch mode to be in batch mode for the entire query, not just for that part of the query.
Yeah. So if I could add this if I wanted to, but that wouldn't make a difference here. But that's something I could do.
If it would make you feel better. Sometimes you just have to write queries that make you feel better.
It's true.
Like drop database, all that stuff. All right, I'm going to steal presenter back, and I'm going to go into to my garbage queries. I'm not nearly as smart as Joe, so my queries aren't as good as his. You're going to have to forgive me. He has a degree in like some sort of math. I can count to here. That's my gift. So before I show, no, because then I'd have to look over here and I'd lose my place. I just get confused somewhere in the middle. There's I don't know where it goes. So before I get into my demo, I need to show you something about the votes table in the Stack Overflow database. For vote type ID, the only two vote type IDs I care about right now are 1 and 2. I don't care what they mean. I don't care what they are. I just want to show you the numbers involved here. Vote type ID 1 has 3.7 million entries in the table. Vote type ID 2 has 37 million IDs and entries in the table. That means that's how many times people have cast that vote in the Stack Overflow database. When I run this query, where I ask for the top 2,500 rows from the post table joined to the votes table, where vote type ID equals 2 and post type ID equals 1, ordered by creation date, this runs very quickly. You barely even notice that did anything. If we go down and look at the messages tab, we did about 29,000 logical reads from the post table, about 29,000 from the votes table, and we hardly even touched our CPUs. We didn't do anything. SQL Server asks for a missing index, right? Which is a stupid missing index when you look at it, because it wants a column that we're joining on and it wants a column that we're ordering by in the includes, and that is just plumb useless. That is not where I want columns that I care about in my indexes. Joe doesn't believe in indexes unless they're a column store. He uses heaps and clustered column store only. He doesn't touch anything else. I'm an OLTP guy. I like to have stuff in the key of my indexes when I care about how I join and I filter and I order and all that stuff. He works in a data warehouse where he just has leisurely amounts of time to do all his funny little tricks. So I've got that query that runs very quickly. But when I turn this query around a little bit, things are going to change. Now, the indexes I have in place here on the votes table, I have the creation date column because I'm ordering by creation date. And I have the vote type ID column because I'm filtering on vote type ID. And I have the post ID column because I'm joining on post type ID. And that's from the votes table. And then in the post table, I have a key in my index on post type ID right there. I don't need the ID column in the index definition because it's a clustered index and it's going to be implicitly present in all my non-clustered indexes. And then I'm just including these 3 columns because all I'm doing is selecting them up here. I'm not doing any filtering, joining, ordering, grouping, anything fun. I don't even know how to write a grouping sets query, so you don't have that to look forward to. But when I run this query where I'm looking for vote type ID 1 instead of vote type ID 2, things are going to change a little bit. This query is going to run long enough for me to text a kissy face to Joe's anime girlfriend, and it's just going to keep on going. This query, all of a sudden, starts taking about 15 seconds just to look for a vote type ID that has fewer entries in the table than the other one. This only has about 3.7 million. Why would this take longer to return absolutely nothing?
You deserve for creating an index.
What? Yeah, I know I do. I'm sorry about that. I should have just used a heap. Everything would have been better. So when I look at what this query got up to, all of a sudden, I'm doing about 11 million reads from these apiece. That's about 23 million reads total. And this query runs serially, so the CPU time is just about dead even with the elapsed time. And this is also pretty god-awful. Well, what happened? Well, it used the exact same query plan as the other one. It did the exact same thing. It just chose really poorly to do the exact same thing. Now, there's no parameters here. There's no parameter sniffing. There's no cache plan. I'm using literals. Each of these queries gets its SQL Server can make whatever plan it wants. It is free to choose, and yet it chooses to do this big dumb idiot of a plan. This is like me. This is like my life as a query plan. So right now it's estimating. It's looking at this and saying, look, I only think about 7,000 rows are going to end up coming out of here, and YOLO all day long. Even though about 3.7 million rows come out, it doesn't change its mind at any point. It doesn't say, oh wait, okay, back up, bad strategy. 7,000 rows, this is okay. 3.7 million, not so much, right? And now we have this happening, and because this produces 3.7 million rows, this key lookup to go get the bounty amount column out of the votes table, well, this ends up executing 3.7 million times, even though SQL Server was only like, 7,000, no biggie. What happened? Why did SQL Server do this? And more importantly, what did we do this index seek another 3.7 million times to produce not a single row? What was on your mind, SQL Server? The crack must have been fantastic. Where did you buy those drugs from? So we did 15 seconds worth of CPU of work, right? CPU and elapsed time was just about dead average. Well, just about the same. 23 million reads. The optimizer chose it free will to do a key lookup there. It could have done anything else in the world, but it chose to spend its time doing a key lookup. That was a bad choice. Somehow, this query that processes 3.7 million rows and does all this work does not cost enough to go parallel. It only costs about 45 query bucks on my home laptop doodad setup. Thanks, Brent. I have cost threshold for parallelism set to 50 because I'm a half decent DBA. I change that setting when things get started. So that query doesn't cost enough to go parallel. It stays serial and it runs for a heck of a long time. And it doesn't return anything. The other query that had to go through 37 million rows, finished in like milliseconds and was just done, right? This one here, forever, 3.7 million, do nothing. What the heck? So I think that plan's dumb, and I want to find out what happens if I tell SQL Server, no, instead of using that non-clustered index and doing that key lookup, what happens if we just use the clustered index instead? And I know Joe is also allergic to clustered indexes. I'm not going to take that personally. But if I go and I run this query where I tell SQL Server, no, just skip that key lookup and use the non-clustered index, this is going to finish a bit quicker. Well, to return nothing, it still takes 5 seconds, and that's pretty weird. But the plan changed, and now SQL Server has chosen to do something else stupid. SQL Server has chosen to sort this data. For some reason, it's going to take all the rows that come out of the votes table, and it's going to sort them. And that sort is going to spill off to disk. Why did SQL Server choose to sort that data? Well, there are all sorts of different kinds of nested loops joins out there in the world. This one here just happens to have this funny little doodad called with ordered prefetch equals true. And now what SQL Server has done is it's resorted the data that came out of the clustered index scan to match the order of the join column that we're hitting in the post table. And when it did that, it spilled a bunch of data out to disk. The SQL Server is being a big dummy today. It chose to ask for a fairly large memory grant. What's that number in real people now? 1,564. It asked for about 150 or so megs of memory. Underestimated that, spilled stuff off to disk just to sort this data to put it in order. But why SQL Server would you take 3.7 million rows and run a nested loops join 3.7 million times to produce 0 rows? If we go and we look at this index seek, we can see that, or we look at this index seek over here, we can see number of executions, all 3.7 million that came out of there. Number of rows, zip, 0, zilch, none, nada. You could write a Disney song about this query. So what happened? What if we tell SQL Server, no, I think nested loops was bad. I think you're a little drunk. on top of the crack use, I think you're also a little intoxicated. This query cost 324 query bucks, which is way more than the 45 that the other one cost, right? So we can see why SQL Server internally was like, no, we're not going to pick that. But now we can clearly see that we have a query that runs for about 1/3 of the time that costs way more. So cost and execution time are just not just not even related. They move different countries and the Neanderthal period. They just they have nothing to do with each other. What if we tell SQL Server, okay, that sort is dumb, that nested loops join is dumb. What if we just get away from the nested loops? What if we do something else? What if we say you can do literally any other kind of join in the world that you want to do, right? So you have the option to do a merge join or a hash join. You just can't do nested loops. It's the only thing that's off the table for you. If we run this query, well, that's going to finish in 2 seconds. So avoiding nested loops, avoiding that sort, and avoiding that other key lookup, we have now gone from 15 seconds down to 2 seconds just by saying no SQL Server, no thank you. I like what you've done in the past, but I'm not sure about this. I don't think you're quite on point today. Now, when we look at this query plan, right? SQL Server chose a hash join, a big bad hash join, big strong hash join, right? Big strong like bear. This is nice because it's not repetitive. We're not stuck in nested loops hell for 3.7 million rows to find nothing, right? It's good, right? We didn't waste a whole bunch of time to come up with nothing. This is a much smarter plan to me. I like this. Joe's going to complain about bitmaps at some point. I'm okay with this bitmap. This is a 2-second bitmap versus a 15-second nested loops join. You can give me that bitmap all day long. when we look at the metrics for this one, well, we did a whole lot less work than we did with those nested loops plans. 243,000 on the votes, 96,000 on posts. We went parallel, so we used a little bit more CPU to reduce the elapsed time, and that's cool, but boy, howdy, this plan was expensive. If we look at the cost of this plan, SQL Server says, oh, man, this is going to cost 330 query bucks to run. There's no way I'm choosing this. And I'm like, okay, but it finishes in 2 seconds, so can we move this up a little bit? I will gladly pay for the faster query. Just tell me what to do. I will solve this problem with money, like bail. So now we have this query that SQL Server will never choose naturally. It'll never say, oh, this is the cheap query, good, we're going to get this one. Under 2 seconds, 0 spills, 330 query bucks. Well, it's interesting because when we had SQL Server choose a different join type, it came up with a more expensive query, but it finished a lot faster. What if we just think that SQL Server chose the wrong join order? Because I remember I joined posts to votes up here, and when SQL Server wrote that first query with the nested loops, the first thing it did was hit the votes table and do that key lookup, and then do a nested loops to post. So what if I just think SQL, you just put the tables in the wrong order, SQL Server. You got a little confused in your inebriated state, and things just got weird. If I do this, what's going to happen? Well, that finishes in about 2 seconds too. SQL Server, you could have just put the tables in a different order, pal, and everything would have been fine. We wouldn't be here talking about this. I wouldn't be pulling your pants down. This is a totally different query plan from the last one. Now SQL Server has chosen a merge join. It says, no, if I have to do things in this order, we're going to merge things together. I'm going to sort everything that comes out of the votes table. We're going to do this merge join because merge needs sorted input from both sides. Right? You can't just have things floating around willy-nilly. Now it's a parallel merge, which is making Joe cringe. I can actually see his bones shaking. He looks at a parallel merge join. But I'm okay with this because still, we're at 2 seconds. We're not at 15 seconds anymore. SQL Server, why? Well, this query costs 443 query bucks for SQL Server to run. Boy, howdy. I'm starting to see a pattern form here. Every query that does better costs more. now SQL Server is like, no, but I got this nice cheap query over here. I'm like, yeah, but it takes you 15 seconds to return no rows, SQL Server. Why? Why do you do this to us? Well, part of the reason is that the optimizer is clearly watching too much anime. The optimizer does not live in reality. The optimizer thinks that it has big muscles and spiky hair. The optimizer is just all wrong about everything that's going on. These queries that cost way more to run, where SQL Server chooses good operators, are way quicker than that cheap plan where SQL Server chose all sorts of dumb operators like key lookups and sorts and other things. I bet if I downloaded Postgres would make much better choices. I think that might work, except Brent doesn't let me have downloads at work. He blocks all downloads after some incidents. Couple minor security incidents when there were some EXEs involved. But I thought they were video games, so you can't really blame me. So hinting the query the way we did is a good way to figure out if the optimizer is wrong. Like maybe you just did something weird. Like, I'm just going to review this together. We're going to figure out what went wrong. And what I kept coming back to when I was looking at this is maybe we can just change the way the optimizer looks at our query. Because you remember when we ran the slow query, and I'm just going to go get the estimated plan for it somewhere up here, I think. Is it you? Yeah, it's you. So when we get this query, when we look at this, we have this top all the way over here. So every time this top runs, SQL Server goes and asks for a row all the way over here, and it has to do all this, and it has to do all this, and SQL Server just make like futzing around. Can I have one? Can I have another row? Can we try this again? Can we try this again? And this top ends up like popping off like 3.7 million times because it's like I only want 2,500, but it keeps not finding anything, so it has to go keep looking. What if I put that top somewhere else in the plan? What if at the end of the day it was kind of my fault? What if I was a bad influence on SQL Server? What if there's a way that I could make that top show up somewhere else? Well, there is. There are ways that you can set funny row goals in other places of your query so that SQL Server will think about the way it's going to write that query plan for you a little bit differently. So if I run this query, I'm going to stick my top 25 in a CTE. I'm going to order by. I'm going to sort of section this thing off. Tell SQL Server maybe just stick this in a corner. Maybe let this hang out by itself. Well, I like how quickly that finishes, even better than 2 seconds. Over in the messages tab, if I look at how much work this thing did, it's about 7,000, 8,000 reads on each table. That's much better than we were doing before, and we're back down to using almost no CPU. This is a pretty good time. I'm enjoying this. Thanks for that, SQL Server. And a big part of why that happened is that top is no longer over here saying, try again, try again, try again. No, it's not. It's over here now. I'm over here now, and it's just going to get 2,500 rows in the order that I want over here, and take those rows and then try to figure out that 2,500 times from over here. That's a much better way of doing things to me. I could also do this with a derived table. There's really no difference. I could stick that top in a derived table, and I could cross apply all the results out to posts. And if I do that, well, that's really quick too. And I know what you're thinking. And I know that when you're looking at this, you're like, but he's not returning any rows. There's no way these results would be right. There's no way that you could possibly do this. I'm still right. Miraculously, somehow. I don't know what happened. This is probably because my wife wasn't involved with this. I wasn't arguing with her. But I'm miraculously right here. Because when I changed the vote type ID that I'm looking for, when I change it back to 2, remember that original one that I looked for that actually returned results? I actually get the same results from both of these, and it's amazing. It's amazing because I've been using SSMS for about a decade, and I still hit the wrong button to run a query sometimes. If I run these two back to back, I get my data in the exact same way. So SQL Server actually comes up with the exact same query plan for both of them, and it says, yeah, if I just stop making bad decisions because you were a bad influence on me as a query writer, all of a sudden I can make better choices, and I can actually have these queries finish in a reasonable amount of time. So thank you for rewriting that for me, because we proved that the optimizer didn't know what it was doing with that first batch, but as soon as we changed a few things, SQL Server was able to come back and really make better choices for us and run queries faster. So that's my gig. You ready, Joe? Do you have any questions on that? No? All right. Cool. All right, I'm going to pass it back over to you. Everyone's too busy trying to giving their SQL Server a blood alcohol test to ask questions. That's fine with me. I got stuff to do later. All right, so I'm going to pass presenter back over to you, and you can.
Am I good?
Yeah, you're good. I can see all of your. Oh God, put that away. Just kidding.
Okay. There's 3 tables here. We don't really need to know much about them. We have a small table, a medium table, and a large table. Now, Eric hacked my computer, and he added a few indexes. It's pretty unfortunate, right? We still have a heap, fortunately. So there are no clustered indexes involved. So that's good. We have 2 non-clustered indexes, one on the IDA column and one on the IDU column. We're going to go ahead and turn off result sets. So the query that we want to run is this one. So I'm joining my small table to my large table on the IDU column, and I'm joining my large table to my medium table on the IDA column. I'd like for this query to take about a few seconds, and it's not.
I'd like a drink, but we're both screwed.
16 minutes. That's how long you gotta last.
Oof.
23 seconds. Okay. Now, this plan is a bit more complicated than you might think. So I'm joining 3 tables together, right? And I don't really have indexes that work well, so I'm getting a lot of hash joins. Okay, that makes sense. SQL Server is saying, what is that, 81 query bucks, so it's a parallel plan. Okay, that makes sense. Here's my scan on small. Here's my scan on medium. But for large, we have this index intersection plan here.
Oh boy.
So the query only needs the IDA and the IDU column. So we have 2 single column non-cluster indexes. We don't have one covering index. We have 2 indexes when combined can be covering. So one of the choices the optimizer has is it can join those indexes together. And it might do that when the table is very large and your indexes are relatively small. So the optimizer thinks, okay, the overhead here of joining together 2 non-cluster indexes is smaller than the scan. Now, this query took 23 seconds. I have these bitmap operators. So all bitmap operator really is a shortcut. It's normally for hash joins. The basic idea is instead of doing the full hash join algorithm for every row on the probe side, instead we'll create this lightweight, small bitmap structure, which allows us to skip some of the rows on the probe side. So if my hash side has a lot of rows, or if my probe side has a lot of rows not present on the hash side, you might see this bitmap. And these bitmap operators are almost always good, except when they're not. You can't directly turn them off, so sometimes you have to live with them. Now, I have a spill here. That's not good. One weird thing is this table has 8 million rows, and I got 8 million rows back. So I wasn't done. So despite this bitmap on column IDA, which was created here, no, it was created here, IDA. None of the rows were filtered out. And if I look at the scan, I see something weird. This is a parallel plan, but there aren't numbers for each thread. And if I go to the parent operator, DOP is 0, query ran serial, and that looks like a serial query, right?
Oh boy, yeah.
So what happened here? I had resource governor turned on.
What?
Resource governor restricts every query to max stop 1. The optimizer doesn't know that. It doesn't know that resource governor is restricting max stop to 1, so it can't factor that into the decision it makes. So it thinks it's going to get a parallel plan, and it creates these 3 bitmaps. Now, row mode bitmaps are only eligible in parallel plans. Now, 2 of these bitmaps are optimized bitmaps. You can see with the OPT here. All an optimized bitmap is this bitmap is created during query optimization, and it can influence query optimization. Whereas there are other bitmaps which are, they're like post-compile bitmaps or something, where they get added in right at the end, at the last second. They don't really change the plan. It's just a way to reduce the cost a little bit. Now, this table has 8 million rows. SQL Server thought the bitmap would reduce the rows to 1.2 million. And that might have happened if the query ran parallel, but it didn't. So this operator doesn't run, this operator doesn't run, bitmap isn't applied, so we get the full result set, and it's supposed to TempDB. So if I'm stuck at max stop 1, I have an angry DBA who doesn't like me. I mean, sometimes pulling that max stop 1 hint, that can make a big difference. So I'm giving the optimizer more information. I'm letting it know, okay, you have to run at max stop 1. So we're in row mode. There are no bitmaps. The optimizer is under no illusion that there will be bitmaps. And even better, our 8 million row table, it's only on the probe side. So before, since I had that index intersection plan, I had an 8 million row result set on the hash side. Now I don't. So all I did was change max stop 4 to max stop 1. I'm not triggering the optimizer anymore, and the query is much more efficient. Now, I can turn off resource governor. Your queries might get downgraded in DOP for other reasons. You might run out of parallel threads, for example. So even if max stop isn't on, you might have this problem still. What can you do about it? Well, first, let's see how things work in the ideal case where I don't get downgraded. Actually wasn't fast. Let's try running that again.
You need more memory.
I probably do. Okay, it's a little faster now. It's a little faster. I mean, it's really not too competitive with the serial plan. It's a little faster. It's no longer 21 seconds, right? Now, what if I want to make this query better? Well, you might know about batch mode bitmap operators. So these work a bit differently than row mode. One of the important ways they work differently is they're eligible for max stop 1 plans. So you might think, okay, if I'm worried about DOP downgrades, maybe I should throw in a CCI into my plan. Maybe that'll help. We'll go ahead and try that.
That doesn't look good.
It's slower.
Not looking good
I
for that
added
one.
batch mode and it got slower. How is that possible? I thought batch mode's always better, right?
What is in 2019? That's what I keep hearing. Everyone tells me that also just runs faster.
Yeah, people say a lot of things, right?
Yes.
I have some batch
especially
mode
to sell
here.
software.
Yes. So part of the query runs in batch mode. A lot of it doesn't, though. Now, SSMS isn't nice enough to tell you at a glance, hey, these operators are in batch mode, these operators are in row mode. It's unfortunate. But when you see these repartitioned streams, that's almost always a sign that operators around there are not running in batch mode. There's a limitation on batch mode. The index intersection plans are not eligible. I end up with a mostly row mode plan. Now this spills the TempDB suddenly, and my estimate went way down. It's only 120,000 rows. So what actually happened here is this batch mode join, it is a bitmap creator. It's creating bitmaps. It's creating a batch mode bitmap.
All these streams and creators, this is like Ghostbusters, man. I don't know what to do.
You can sit back and relax. That's all you have to do.
I don't have a chair. I'll fall.
All right. Here is our batch mode bitmap. It's in this filter operator. It can't be pushed all the way through to the hash join. And I mean, that makes sense. So this filter is on the IDU column. This index scan is IDA. This index scan is IDU. So of course this filter can't be pushed, right? Like the column isn't there yet. The column isn't in the results set until here. It's just not output yet.
Son of a gun. That seems suboptimal to me.
What's really suboptimal is the expected cardinality estimate reduction from this bitmap is pushed. This is 120,000 rows. It's the same thing. So this is a bug. The optimizer makes a mistake wherein it pushes the cardinality estimate reduction onwards, but not the filter. So as a result, our estimate is way off. This operator just doesn't get enough memory.
SQL Server is dumb.
So bitmap filters or bitmap operators, they're normally very helpful. There's some edge cases where they're not helpful. There are bugs sometimes with the batch mode variety. And if you get a serial plan, whereas SQL Server thought it would be parallel, you can run the problems. We have time for quick questions if there are any.
No questions yet, but we do have someone typing. So who knows? Maybe
I hope they type quickly.
I don't know. It's only Nico next. If we go a little over, that's fine. What's he going to do? Get on a boat?
He does live very far away from us.
He does. It would take him a long time to punch either of us.
Yes.
All right. No questions, so we are going to trudge forward.
No questions. This is the last demo of session. I have a very simple table here, 3 columns, sales date, the amount sold, and was it a robot sale? So I employ both robots and non-robots. Some of the robots make sales too. The robots work very hard.
Very fair.
There are no indexes except the column store. So I have a column store index defined on my table. Now, I have some suspicions about my non-robot workers. I feel like when we get to the last month of the year on Friday, they don't work very hard. So I'm going to write a query where I want all of the Fridays of this month where I didn't make any sales that were by a human, right?
Lazy humans.
Lazy humans. I mean, maybe the robots deserve our jobs after all.
Someone ought to annihilate them.
The humans or the robots?
Humans, useless.
Oh, okay.
I don't know if you saw the career talk, but we're all destined to be in sales, so this is like the worst possible outcome.
Now, robots might have infinite patience, but I don't. I mean, 12 seconds. Let me turn results. I'm only getting back 4 rows. That won't hurt anyone, right?
I don't know.
Well,
0 rows
12
really
seconds
hurt
for
me,
4 rows. I mean, that's like 3 seconds per row, right?
at least.
I could write those rows out faster with pen and paper.
Little red markers.
So there's this top operator here. I didn't ask for a top. The optimizer added one. This top is really unfortunate. This is a left anti-semi join, so the inner side would quit early anyway when it finds the first row. The optimizer just adds this top for optimizer reasons that aren't very good. The result of this top is this reduces the cost of the query plan more than it should. So SQL Server thinks this query plan, it's only 19 query sets, but it took 12 seconds. So there's something way off with the cost estimation. And it thought that this scan was 59% of the cost. The scan took 1 millisecond, right? So it's crazy. So this is not the kind of plan you want to see with column store. I have my column store on the inner side of nested loop. It's running in row mode. I have 36 million rows, but I read 129 million. This is horrible. This is a horrible plan.
Everything went wrong. No. Spinning out of control.
Pretty much everything went wrong. That is true. Now, this is caused by a row goal. So the row goal optimization isn't always bad. It can be very helpful. The idea is, if at any point in the plan, I don't need the full result set, maybe there's a more efficient way to get only the rows I need. So if you imagine a well-indexed query written by Erik, if I only need the first row, it might be faster to build a plan designed to get that first row instead of all the rows. Here, there's a row goal added. It's terrible. It causes problems. So how can I make this query faster? Maybe I'll just brute force it, right? And add an undocumented trace flag, make it run in parallel. Parallelism is good, right?
Always.
Right?
Yeah. The more
always, the man says. All right, so I got a little faster. Not really. Okay.
Well, something seconds a row. I don't know what 9 divided by.
So I'm running a max.4. If I have no weights and perfect efficiency, I want to see a CPU time to elapsed time ratio of 4.0. Instead, it's like 1.3.
Lofty goals from you, huh?
I demand the best. We can look at weights. There aren't any weights here. Well, we have like 100 milliseconds of weights, so it's not weights. All right. So optimizing by weights just doesn't work.
Oh, you.
Look at thread 2 and thread 3. They did nothing. They didn't help at all.
Robots.
This query might as well have been run at max stop 2. So why did this happen? Go the outer side, which drives the loop. 2 and 3 don't get a row. So I'm only pulling back 4 rows from this scan. There are only 4 Fridays in this month after all. And the smallest unit that the demand-based scan can pull back is a page. So if I have 4 rows, 3 rows on one data page and 1 on the other, there has to be 2 threads that don't do anything. There just aren't enough rows here. The data isn't spread out well enough to get even distribution of work over all my threads.
I thought you just let them join a thread union.
I'm going to twist SQL Server, bend it to my will. I'm going to add a top. To fix harm with the top, all I'm doing is I took that data dimension query, put it in a drive table, added an arbitrarily large top. You can use your phone number. I didn't because I don't have one. You can use the big int max, the int max, whatever you want. Now SQL Server has to guarantee correctness, so it'll enforce this top. And when we enforce the top, we have this gather streams, this round robin distribute streams. So now the rows are forced to be evenly distributed, 1 for each thread, and the query is faster. Now this still isn't a good query, right? I mean, we're still reading 129 million rows. It's just more parallel. If I rewrite my date dimension filter, so I'm filtering directly on the date, which is the column I'm joining on, the optimizer can push that filter down. So I'm pushing the filter down. I loaded my data in order of sales days. So SQL Server can use the metadata for the compressed row groups to skip almost all of the I/O, which is what you see here. So the query is very fast. So this is still like a bad column store plan, but I'm reading so little data from it that the top isn't nearly as harmful.
Okay.
I haven't really fixed the fundamental problem. I've just made the query more efficient. The fundamental problem is this row goal optimization. The top isn't helpful. The top reduced the cost of this plan way too much. So this apparently happened often enough that Microsoft created a use hint just for this. Go ahead and run it.
Don't lie, it was just for you.
It was not for me. It was, I had no influence here.
Mm-hmm.
So we're up to 4 query bucks, but this query is even faster. Now we have a hash join. Hash joins are generally what you want for column store. We only scan the column store once. So here, the row goal that was introduced by the not exists was very unhelpful. It tilted the optimizer to pick a bad plan. And another option you have is you can just say, okay, I know I want a hash join, give me a hash join. Any questions? Otherwise, you can lead us out.
Nope. Kenneth commented, that sounds like a great way to confuse a coworker by putting that top in big int max in there without a comment. But you know, comments take up space and time, and we don't have unlimited space and time.
Yeah, if you find yourself stuck in a situation where that's the way to fix the query, having a comment is probably what you want to do.
I don't know. I don't put comments in any of the Blitz code because I don't know. If anyone's unfortunate enough to read it, I don't think they're gonna have fun anyway. It doesn't.
If you use your phone number, then the coworker can just call you with questions.
Yeah, I'm not doing that. Not one bit. Not one bit. I'm gonna use someone else's phone number. All right. So what did we just do? We just saw SQL Server make a bunch of really bad choices based on what it thought made sense from a cost-based perspective, where every time we ran a query, SQL Server would no, it'll be much cheaper if I do this, if I take this shortcut, if I use this operator. But every single time, SQL Server was just wrong. The optimizer makes these choices again based on how much it thinks things will cost to do. That cost is in arbitrary measurements of CPU and I/O, which don't really mean anything anymore. It's just these funny little decimal numbers that it sticks in plans to look fancy, I think. I mean, I don't really ask why. But just keep in mind that the optimizer's job isn't to find a perfect plan. It's not the optimizer's job to say, every single time you run a query, I'm going to go to the bank on this. I'm going to figure out what the absolute best plan is. I'm going to test different plans. I'm going to do all this stuff. It doesn't do that. It's like you at last call, and it's just like, I want a cheap plan. I want it good, and I want it fast, and that's it. Like, just good enough, get out the door, done. Does not spend a lot of time thinking about you. Sometimes that bad plan is your fault for all the blah, blah stuff that you've heard a million times of best practices with the functions and the indexes and the yada, yada. Boring, right? Sometimes when that bad plan isn't your fault, well, that's because the optimizer has that jar of desk whiskey too. Right now, there are still no robots that go and fix this stuff. There's no one popping up to say, oh, I have a really good idea here. I'm going to go behind the scenes. I'm going to go tweak and tune this thing and make it better. If you follow those best practices from the blah, blah stuff and you still have these problems, congratulations, you have an interesting job. Because remember, these are choices that the optimizer thinks were really good. These are things the optimizer is like, yeah, they're going to be blown away by this. But it ends up being terrible. It's up to you to track this stuff down in query. Track the queries down, then track it down in the query plan, do all this stuff and like figure out what's wrong and like really get your little baby fingers dirty on that stuff. If you can do that, you are safely employed, at least until the robots have come along and assimilated you entirely. That's all for us today. I think we finished in a pretty wonderfully on time, prompt manner.